In this video, we will learn about solving linear inequalities. So first up, what is an inequality? So we have these symbols, less than, greater than, less than or equal to, greater than or equal to. How do we use them? What do they mean? So we could say, numerically, we could just say, we have the number 3, we have the number 5, put the proper symbol inside, like this. 3 is less than 5. We could also kind of read it backwards. 5 is greater than 3. Okay? Now we're going to do it with algebra. X is greater than 3. So this means x can be any value bigger than 3. It can be 3.001, 3.5, 4, 5, 10, 20.23, anything. So we can show the solution also on a number line. Okay, so the values of x could be anything, not including 3, that is greater than 3. So all the solutions are on this side of 3 on the number line. The open circle shows us we're getting very, very, very close to 3, but we are not including 3. If we had greater than or equal to 3, well, then we would fill in the circle and then also include these values. Okay? If we had x is less than 3, then this would be all the values less than 3. 2.99, 2.5, 1, 0.5, 0.01, the square root of 3, all kinds of numbers here would be less than 3. So it's different than just saying x is equal to 3. That gives you one solution. When we're using the inequality symbols, we're getting a whole interval of solutions. We can also think about it graphically if we had more of a linear equation. So if we had a linear equation, y is equal to 2x plus 1, this would look like y-intercept of 1, a slope of 2, so we have something something like that. This is the line y is equal to 2x plus 1. Now if we wanted to ask a question like, where is 2x plus 1 greater than 3, we'd be asking, when is the line above 3? When is it greater than 3? So it's greater than 3 on this part of the line. What x values would that correspond to? Everything that's greater than 1. So if we had to solve this inequality graphically, we can solve it and say that x is greater than 1. Okay? Now we're actually going to do solutions algebraically, but having a graphical understanding is great for checking your work, making sure that it makes sense, doing a quick sketch. So this first question, solve. We solve it just like a linear equation. Everything's very straightforward in this question. Later on, we have to think things through a little bit more. So for a linear equation, we would do a balancing step, get rid of 2 from both sides, so x is equal to 5 minus 2. We're not doing equality here though, we have an inequality, so x is greater than 5 minus 2, so x is greater than 3. Okay? So we saw this on the number line earlier. We could think about the solution as everything that's greater than 3. Does this make sense? We could do a quick sketch of the graph too and make sure that it makes sense. So we have a y-intercept. If we treat this as our graph here, we have a y-intercept of 2, y-intercept of 2, and a slope of 1, so it's 1 over 1. So over 1, up 1. And our graph looks something like this. And now, where is it greater than 5? Well, 5 is 1, 2, 3, 4. 5 is about there. When is the function greater than 5? From this point onwards, the function's greater than 5. And that does look like when x is greater than 3, the line is greater than 5. So that works out. Okay, now what about this question? If we use the same strategies, we just do straight up solving. We divide both sides by 3, by negative 3, we'd have x is less than 3 divided by negative 3, x is less than negative 1. Okay, we can check this. We could do a quick sketch like we did before. So we can graph negative 3x. 0 is the y-intercept with a very steep slope. Okay, when is it less than 3? Less than 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. When is it less than 3? It looks like it's less than 3 right along here. So for x, values that are less than, greater than negative 1. Uh-oh. We had less than negative 1. So we had this part. We had where the function's greater than 3. This isn't working. Let's do a formal check. Okay, so for a formal check, usually we sub in solutions into the left side and the right side. So if x is less than negative 1, possible solutions could be anything that's less than negative 1. So x is equal to negative 2. X is equal to negative 2. We'd expect that to work. And so we expect that one to work. And things that are not in the solution, x is less than negative 1. So the opposite of that is x greater than negative 1. So x equals 0 shouldn't satisfy the equation. This should be an x. So let's check that. So left side, right side. We're going to check x is equal to negative 2, and we're expecting this to work. On the left side, we have negative 3x, so negative 3 times negative 2, and this gives us positive 6. On the right side, we have 3. Is 6 less than, we want left side's less than right side, is 6 less than 3? No, 6 is greater than 3. So this solution does not work. That tells us that x less than negative 1 does not work. Let's just try the other side. So we're going to test x is equal to 0. We can think of our number line here. We had negative 1. We just checked -2, and it failed. Now we're checking on the other side. We're checking 0 to see if that works. So the left side, again, we have -3x. We sub in 0. It gives us 0. And we're expecting the left side to be less than the right side. That's what we want. Let's check the right side. It's 3. Is 0 less than 3? Yes. Okay, so we're seeing that values to the right, values greater than -1, are actually working. Okay, and the reason for this is dividing by negatives in inequalities doesn't really work. We can't do it exactly the same way as we did with linear equations. So for an inequality, this didn't work. Let's try again. Okay, so the big problem is the negative. How can we get rid of this negative? Well, what if we just do a different set of balancing steps so we can get this the other side so it can be positive? So we'll add 3x to both sides. And now we have 0 less than 3 plus 3x. Let's take away 3 from both sides. Okay, and now we're going to go through the rest of the solving steps. I just want to point out, first of all, look at the equation here compared to the equation here. I've gotten rid of the negative, and I have 3x is greater than 3. Over here on the left-hand side, I had -3x is less than 3. Uh-oh. -3. There we go. So 3x is greater than -3. Here, if I just divide by -1, I would have 3x is less than -3. So you can't just do straight division or multiplication by a negative. If you do, you have to flip the inequality. You're flipping the inequality because it's the same as rearranging across the inequality symbol. So from here, you can continue to isolate x, divide both sides by 3. So x is greater than -1. Again, we can write it on a number line and check to make sure that this works. So we know we're dealing with -1, and we already did the checks. When we subbed in -2, -2 gave us +6, and that was not part of the solution. But when we subbed in 0, we had 0 times 3 is 0. 0 is less than 3 is correct. So x is greater than -1 makes sense. So the takeaway from this example is, if you multiply or divide by a negative, you have to flip the inequality. That's the shortcut instead of doing all these steps. So let's do a similar example. So if you have -2x is greater than or equal to 8, to solve this, I could divide both sides by -2. But when I do that division, I have to flip the inequality to the opposite direction. And the solution should be x is less than or equal to -4. So let's do that, a quick check on the number line. So we have -4 here. We want to check a value that's less than -4 and a value that's greater than -4 and see if it works. So in this case, 4 should be a solution. We should be able to sub 4 back in and it should work. So let's test that out. If I sub 4 back into the equation, negative 4, sorry, negative 2 times negative 4 is equal to 8. 8 is equal to 8, so that checks out. Great. Let's check negative 5. Are we expecting negative 5? Less than or equal to negative 4. Yes, we're expecting negative 5 to work. So let's try it. Negative 2 times negative 5 is equal to 10. 10, so 10 greater than or equal to 8. Yes, 10 is greater than or equal to 8. And we're expecting negative 3 not to work because x has to be less than negative 4 and negative 3 is greater than. So let's try that out. Negative 2 times negative 3 is equal to 6. Is 6 greater than 8? No, 6 is not greater than 8. So x, we definitely don't want anything on that side. So we'd expect our solution to be negative 4 and everything less than negative 4. Good. Negative 4 and everything less than negative 4. Perfect. Okay, one more slightly more complicated. Remember, we can use our regular linear solving steps, and just be careful if you multiply or divide by a negative. So in this case, we want to collect all our like terms together because we have more than one x on either side of the equation. Right now this x is being divided by 2. It would be really handy just to be able to get rid of that divided by negative 2, so we'll multiply both sides by 2. So these 2's cancel. We'll start to expand 2x minus 10 because we distributed the 2 in. It's greater than or equal to x minus 6. Let's put all our x's on the left and all our numbers on the right. So I'm going to subtract x from both sides. Let me write it out so hopefully I don't make a mistake. So I have 2x minus x is just 1x. And then the 10, I'm going to add 10 to both sides. Minus 6 plus 10, so I start down below 0, go up 10, I have 4. So the solution should be x is greater than or equal to 4. Let's do a check. It's so easy to make a slip up, so it makes sense to check your solutions. So we have 4, and we want to check below 4, and we want to check above 4. So let's check by subbing in 3 into the equation and see if it works out. So 3 minus 5 greater than or equal to 3 minus 6 over 2, minus 2 greater than or equal to 3 minus 6 is negative 3 over 2, negative 3 over 2. Sometimes it's easier to compare numbers as decimals instead of fractions. So this is negative 1.5. Okay, so is negative 2 greater than negative 1.5? No, negative 2 is not. So this is not a solution. Okay, let's do 4 now. 4 minus 5 greater than or equal to 4 minus 6 over 2. Negative 1 greater than or equal to negative 2 over 2. Negative 1 greater than or equal to negative 1. Okay, yes, it's equal to itself. So 4 is definitely in the solution. Let's try 5. 5 minus 5 greater than or equal to 5 minus 6 over 2. 0 greater than or equal to negative 1 over 2. So negative 1/2. Is 0 greater than negative 1/2? It sure is. So that checks out, and we definitely have the solution that 4 is part of the solution and everything greater than 4. And that was exactly what we got. Perfect. It's always nice to be able to check your work and know you're right. So this example is a little bit different. It has 2 inequality symbols. Here and here. So we have negative 3x plus 4 is greater than negative 8, and it is also less than 1. technically we could work this out by breaking it into parts. We could do negative 3x plus 4 is greater than negative 8, and we could do a second piece of work for negative 3x plus 4 is less than 1. But really all the solving steps would be the same. We would try to isolate x. So we would first get rid of the 4. So we'd move the 4 over, minus 4, and here minus 4, minus 4. So you're left with negative 3x is greater than negative 12, negative 3x negative 3x is less than negative 3. Great. And then the next step is to get rid of that negative 3. So we're going to divide by negative 3 and we're going to have to flip the inequality. Okay, and we're going to have to flip that. Same thing over here, divide by negative 3. And we're going to have to flip the inequality. And flip the other way. Almost confused me for a second there. So x, we have negative 12 divided by negative 3. Negative 3 goes into negative 12 4 times. So x is less than 4. And over here, x is greater than 1. We can bring this back together. X is less than 4, greater than 1. So x is greater than 1 and less than 4. And this is our final solution. Our final solution looks a lot like the beginning where we had a double inequality. And really, instead of spreading this apart and then putting it back together, we could do this all together in one step because all the steps really are the same. So the first thing we did was we subtracted 4. And remember, we subtract 4 from every single part because it's really like two inequalities in one. So we have negative 8 minus 4 less than negative 3x less than 1 minus 4. Okay, so negative 8 minus 4 is negative 12. It's less than negative 3x less than negative 3. Okay, we're going to do dividing by negative 3. And remember, when we divide by a negative, hopefully you're saying, flip the inequality. Okay, so we flip the inequalities. We have 4x greater than 1. Now, the one thing we have to do is rewrite this because we always start with the smallest number first. 1 less than x less than 4. If we wanted to check this, what do we need to do to check it? Well, what would it look like on a number line? Two, 3, 4, 5. Okay, so if this is right, x is greater than 1, so x is these values here until you get to 4, and it's less than but not including 4. So we'd expect these values to be true. So we need to test each interval. We need to test each section. We need a value from less than 1, a value between 1 and 4, and a value more than 4 to make sure that all these intervals are indeed solutions or are not solutions. I'm going to get a little bit more paper space here. Okay. So to check each of these, we need to know the original inequality. Negative 8 less than negative 3x plus 4 less than 1. and we need to check these intervals. So first let's check x is equal to 0. It's outside of the answer we found, so it shouldn't satisfy the equation. So let's sub that into the equation. Negative 8 less than negative 3, 0, plus 4 less than 1. Okay? So negative 8 is less than 0 plus 4 is less than 1. So, is this true? Is 4 greater than negative 8? Yes. Is 4 less than 1? No. So, it doesn't satisfy the inequality. Okay? For the middle interval, let's pick, you could pick 2, you could pick 3, you could pick 2.5, you could pick anything between 1 and 4. Let's pick 2, it's a nice number, so let's test x is equal to 2. I'm going to put, okay, negative 8 is less than, I'm just going to do a little bit of steps in my head here, negative 3 times 2 is negative 6, negative 6 plus 4 less than 1, negative 8 less than negative 2 less than 1. Okay, does it satisfy? Is negative 2 greater than negative 8? Yes. Is negative 2 less than 1? Yes. So this is true. Great, we wanted that interval. Now we need to test above at the 5. So let's check x is equal to 5. Negative 8 less than negative 3 times 5 plus 4 less than 1. Okay, is negative 11 greater than negative 8? No. So it doesn't even matter whether or not it's less than 1. It is, but it's not greater than negative 8. So it fails. Fails. And our solution is definitely between negative 1 and negative 4. Okay, takeaway on this one. You can solve a double inequality just like solving all the other inequalities. Just whatever you do to one side, you do to every single section. So instead of saying what you do to one side, you do to the other, you can say what you do to one section, you do to all of the sections.